So this video lesson is all about proportions, and I should say it's the first video lesson about proportions, because in this one we're going to look at specifically what is a proportion, that is, how can we define proportions, and starting to look at how we solve them. In a separate video lesson we'll look at what it means to write a proportion from a scenario, from a word problem, but for the moment all we're looking at is defining and solving a proportion. So what I want to look at first is two different rectangles. And we know that these rectangles have the same ratio of length to width. That is, if we set the length and the width of the smaller rectangle, which we'll call this rectangle 1, and we'll call this rectangle 2. If we set the length and width in a ratio, that same ratio would have to be true for the length and width of rectangle 2. Now, if we look at these in terms of how we actually write the ratios, we can write the ratio of length to width in triangle 1 as 25:10 with a colon. I'm going to skip the writing of ratio using the word 2 because we're just going to talk with the word 2. It's technically a correct way of writing the ratio, but not used necessarily in practice in solving proportions, or we write it as a fraction. So both of these, length to width, represent the ratio for triangle 1. Now, for triangle 2, we're not exactly sure what the length is. So we can't exactly just put question mark over 20. So what we do is we'll make this an x. A placeholder variable just to say we know that this length is something, and we know that the ratio of length to width is either x to 20 or x to 20. And if we know that the same ratio of length and width is true for rectangle 1 and rectangle 2, we can actually take these two ratios and set them equal to each other because the ratios are the same. 25:10 is the same as some unknown x to 20. And what we have right here, this setting equal of ratios because they represent the exact same thing, particularly when we have an unknown value like this variable, that is a proportion. Setting two ratios equal to each other, provided you know that they're equal to each other, gives you what's called a proportion, and that really is just what the definition of a proportion is. Two ratios that are set equal. Well, now we have some numbers, we have a variable x, and the next logical question then is, how do we find out what x is? Or, how do we solve this? How do you find x? So what I would invite you to do is pause the video here for a second, see what you can come up with based on what you know of solving equations, and see what you can find for x. How do we solve for x? And see if you can figure out y too. Well, there are two different ways that we could really look at solving for x in this case. The first one involves something that's pretty familiar with fractions, and that's finding a common denominator. So first, we got to figure out what the common denominator for 10 and 20 is. In this case, the least common denominator, although we could use any common denominator, but the least common denominator is just 20. So in this case, LCD equals 20. Now this is an easy example, and intentionally so that we can look at both of these styles and not worry too much about the math, but in order to make both fractions have a denominator of 20, you just need to multiply the fraction for triangle 1, the ratio 25/10, by 2/2, numerator and denominator. Then you get 50/20 is equal to x/20. Now, we haven't talked specifically about how we can do this, but if we look at the denominators, they're both equal to 20. That means if these two fractions are equal, whatever's in their numerators has to represent the same value also, because otherwise the two fractions with the same denominator out of 20 would give us different results. Clearly, 50 out of 20 can't be the same as 45 out of 20, 40 out of 20, 23 out of 20, 70 out of 20. So then x then has to equal 50. The other way we could look at it with the common denominators is just multiplying both sides of the equation, because we have the equation here, by something. But that's really what we're getting at when we talk about style number 2, clearing denominators. Now, in this case, we're relying on something different, which is not that we can multiply numerator and denominator of a fraction by the same number to give us an equivalent fraction. We're looking at this equal sign. This is an equation, and no matter what number we multiply or divide by either side of the equation, except for dividing by 0, of course, we get an equation with the same solution. So what I'm going to do is I'm going to multiply some things by this equation, and I'm going to get rid of the denominators to make it simpler to see. Well, we're going to start out with x over 20. Well, if we wanted to get rid of the 20 there, we would just multiply by 20. The x is divided by 20, so we can get rid of it by multiplying. Now this, in and of itself, gives us a solution that we can find. 20 times 25 divided by 10 is equal to x, because we can cross this out here. But I'm not going to stop there. I really want to get rid of these denominators. And if the numbers are more difficult than this, or if, for example, you have more than one variable, you got to get rid of both denominators. So I'm going to multiply by 10 now. Why? That 10 is rid there. And I'll just make a mark here because I'm running out of space. What we have left, we have 10 times 20 times 25 divided by 10. The 10s cancel out on the left-hand side. 20 times 25. On the right-hand side, we have 10x, because the 20s cancel out. Now, yes, did I make this slightly more difficult by bringing the denominator back over to the x? Yes, but here's why. But I'll explain why here in a second. After we go through this, 500 equals 10x. Divide both sides by 10. And we get 50 equals x. Now the question arises, why in the world did I bring the 10 back over? Well, it's to illustrate the next point. So let's take a look at what it really means when we're going through the process of clearing denominators. The first thing that we did is we multiplied both left and right side by the same number. Why can I just multiply the numerators and not the denominators in this case? Why? Because we're solving an equation, which means I can do whatever operation I need to both sides of the equation as long as I do it equally, and it's the exact same operation. In this case, we multiplied both fractions by a 20 over 1 or a 10 over 1, a 20 over 1 and a 10 over 1. Because they are fractions, so we had to multiply something by the denominator, and 20 and 10 are both integers, so 20 over 1, 10 over 1. What does that mean? Well, in the next sense, when we get rid of all the extra there, we can get rid of the 10s and get rid of the 20s, and that leaves us 25 times 20 is equal to 10x. Now, I didn't color code what I'm writing down here, but I'll skip ahead in this solving of the equation here. That should be a 0. 50 equals x. But I want you to do something for a second. I want you to look at this compared to this. What do you notice about the numbers in 25 times 20 equals 10x? Well, when we've gotten through it and we've gotten through the entire thing, and we compare, we notice that 25 times 20 are on opposite fractions, and 10 and x are on opposite fractions, but they're also in opposite parts of the fraction. 25 is the numerator of the first fraction. 20 is the denominator of the second. X is the numerator of the second fraction. 10 is the denominator of the first. And what this is, when you transform this fraction, or these equalities for fractions, down into this form, where you multiply across the equals sign, numerators by denominators, you're taking what's called a cross product. And what we can actually do with a cross product, because this works for every single pair of fractions that have an equal sign between them, and you're invited to see even find some equivalent fractions, 1/2 and 2/4, 3/6 and 10/20. And see that this is true for yourself also, but what we can do is we can skip the step with the x on it when we clear and just go immediately to the cross product. 25 times 20 is the same as 10 times x. Now it gives us an equation that we can solve, less complicated than the fractions. Now, can you take the step of just multiplying by 20 and figuring that out? Yes, of course you can. But what I want you to do for these next several is practice using cross products. So one more time, setting two ratios equal gives you a proportion, and when you solve a proportion, you use what's called a cross product, which is where you multiply one numerator by the opposite denominator and the other numerator by that first denominator and set those two equal to each other. But why can we do that? Because we are clearing the denominators from both fractions. So go ahead, pause the video, and take a second to solve each of the proportions that you see, and then unpause the video and we'll come back and find the solution. Okay, so in the first proportion in the upper left-hand corner, we'll label these 1, 2, 3, 4. In the first proportion in the upper left-hand corner, when we take our cross products, we get 50x. I just like putting the x on this side. It's an equal sign. You can put them on whatever end. 15 times 30 is 450. Divide both sides by 50. X is equal to 9. For number 2, x over 12 equals 2.5 over 12.5. Now we can go through this, multiply 12 times 2.5 and 12.5 times x. But I'm going to take one extra step here before, and I'm going to divide. I'm going to multiply numerator and denominator of the second fraction by 10. So I now get x over 12 is equal to 25 over 125. Now I can do that because I'm taking a fraction. I'm creating an equivalent fraction, in this case an equivalent ratio. Once I do that, I can see that 25 divided by 125 is the same as 1/5. So x over 12 equals 1 over 5. Now we take the cross products. 5x is equal to 12. And x is then equal to, in fraction form, 12/5. Or in decimal form, 2.4. For number 3, we have 20 divided by 45 equals 8 over x. Now we'll stop with this one because we only have integers. And we'll take the cross product here. 20x equals 8 times 45. I know that 8 times 45 is equal to 360. So then x must be equal to 18 once we divide both sides by 20. And finally, 7.2 over x is equal to 2.4 over 1.8. Now, we can go through, we can multiply the decimals here too. But one of our things that we should always look at, like we did for number 2, is there some way that we can make this process easier? We can use fraction simplification and equivalent fractions and ratios to change these numbers a little bit, as long as we don't interrupt what the ratio is. Well, 2.4 over 1.8 is the same as 24 over 18. 24 over 18 divided both by 6 is the same as 4/3. So 7.2 divided by x is equal to 4 over 3. What that gives us is that 4x is equal to 21.6. X then, when we divide by 4, gives us an answer of 5.4. So again, when we solve any proportion, which is just the setting equal of two different ratios, we can use this thing called a cross product, where it allows us to clear the denominators but skip the step where we actually do the multiplication because it works for every fraction. We've seen it in operation here. So to solve a proportion, take the cross product.